Welcome to the deep dive. Today, we're really getting into the weeds on a pretty ambitious blockchain setup. We're talking about the NetX chain-native technology stack. It's this, well, multi-layered system aiming to solve some big problems in the decentralized space. You know, trust, computation, right up to the apps people use. NetX is trying to build a whole ecosystem.
Yeah, and what's really interesting, I think, is how NetX is looking at the whole picture, a holistic solution. It's not just, focusing on one single layer. They're building this integrated chain-native technology stack. So our goal today is basically to unpack all the pieces, this four-layer system, and really understand how it's supposed to work, deliver that decentralized, secure, efficient environment.
Okay, maybe let's just take a step back for a second, lay some groundwork. A lot of projects, they hit this wall, right? The trade-offs between speed, security, decentralization. So what exactly is a layered architecture in blockchain? And why is it, so important for tackling those real-world issues?
Right, that's fundamental. The whole point of layering is to split things up, separate concerns into different specialized layers. So instead of one layer trying to juggle everything, basic security, app logic, everything, you have dedicated layers for specific jobs. And that's, well, it's become pretty crucial for getting better scalability, better security, more specialization. NetX really leans into this, not just layers, but this interconnected chain-native technology stack. We'll look at layer Mesh 1, the trust layer, then layer 0, resources, layer 1, system, and layer 2, services. But the key thing, really, is that they're not just stacked on top of each other like pancakes. They interact deeply. It allows for, specific functions and better performance across the whole thing.
Okay, got it. Let's start right at the bottom then. Layer Nash 1, the trust layer. That name alone sounds critical. In a space where people are often, let's say, skeptical about security, how do you actually build verifiable trust right from the start?
Exactly. Layer Mesh 1 is, it's the absolute foundation for NetX's security and integrity. It's just one component. TRIAS, that's the Decentralized Trusted Computing Network. Its main job is tackling information asymmetry, basically, figuring out if nodes are trustworthy. Think about those security chips in modern hardware. TRIAS uses that kind of tech-trusted computing protocols. It essentially fingerprints all the software on a node. OS, libraries, apps, the whole stack. It creates this unique, verifiable record proof that the software hasn't been messed with. And this integrity data gets stored on the TRIAS ledger, so anyone can check it.
Okay, so it's like a crypto check on the software's DNA, making sure it's the real deal. But how does that check then spread across the network? How do you build actual trust from that? Seems like a huge job.
You got it. And TRIAS uses three main steps for that. First, like we said, trusted attestation and verification. Nodes check out their peers, verify their software, store that proof. Second is verification gossip. Once a node verifies another, it tells its neighbors, peer-to-peer gossip. This info kind of ripples out node by node, building up this network-wide picture, this web of trust. Everyone knows who's verified and how they behave.
So it's not just one node saying, I trust you. It's the community building consensus on who's trustworthy.
Precisely. Which brings us to the third step, POET consensus, proof of embedded trust. Now, this isn't your typical proof of work or proof of stake. Consensus here is built on trustworthiness itself. It's based on a node's reputation and its connections within that web of trust. It models how behavior changes ripple through, figuring out reliability based on where a node sits in that trust network, kind of like how trust works in real life, right? Based on your connections and reputation. It's a totally different way to secure the network based on verifiable reputation. So this layer, it's the security bedrock, the information discrepancy compensator for all of NetX.
That's really interesting. So layer Mesh 1 gives us this solid, verifiable trust foundation. Now, with that trust sorted, we move up to layer 0, the resource layer. So where do the trusted computing power and data handling come from to actually build things?
Yet layer 0 is where those resources live, and importantly, they rely on that trust from TRIAS. Two main parts here, Leviatom for decentralized computing and Behemotum for private data services. So Leviatom, think of it as a decentralized cloud computing infrastructure network, like a global decentralized AWS Lambda or Google Cloud Functions, sort of. It manages computing nodes, schedules microservices. It basically becomes a DFAS platform decentralized function as a service. It does this with property-based service routing, smartly sending tasks to the right node. It keeps track of what microservices can do in its Leviatom ledger, and crucially, that ledger is verified by the layer Mesh 1 web of trust. And this is big because layer 1 chains, EVM chains, can then call these complex off-chain microservices. They can check the ledger for functions, agree on the results of these DFAS jobs, all with that underlying trust.
Wow, okay. So you get verifiable off-chain computation, usable by smart contracts without losing trust. That's huge. But what about big data? Sensitive data, that's always a major hurdle, securing that properly.
Right, and that's Behemotum's job. It's a privacy-preserving data service network specifically for large data sets.
Hmm.
It uses pretty advanced privacy tech things like differential privacy, homomorphic encryption. This means you can process or analyze data without actually exposing the raw, sensitive information itself. Super important. Smart contracts are used here too, defining how data gets trained, who accesses models, how people get paid for data work. The info mentions benefits like, user control, transparency, security, scalability. But the real kicker is that privacy-preserving aspect for big data. It lets you use data without leaking it.
Okay, so layer 0 is the decentralized engine room, providing trusted compute and private data handling. So we have trust, we have resources. Now layer 1, the system layer. This sounds like where it all comes together, the core blockchain stuff. What's its role connecting these lower layers to the apps we'll see later?
You nailed it. Layer 1 is where the main engine fires up. It hosts the EVM-compatible chains. And it also has these DevOps tool chains for managing the whole life cycle of applications running on the chain. It's really the critical bridge between the layer Natcha 10 infrastructure down below and the layer 2 applications up top. Three main parts again: the NetX Smart Chain, Divina, and Triathon.
Let's start with the NetX Smart Chain. How does it actually use those lower layers to get the kind of scalability and speed that, well, many chains struggle with?
So the NetX Smart Chain, it's EVM compatible, built right on top of layer -1 and 0. It gets its performance boost in a few ways. First, there's the shared trusted base. All the nodes are linked through that layer -1 web of trust so they can verify each other. This means you can potentially run faster with fewer layer 1 nodes because the deep trust comes from layer -1. It cleverly separates verifying the system's integrity from verifying transactions.
Ah, that's smart. Faster layer 1 without sacrificing the depth security.
Exactly. Then there's heterogeneous deployment. You can set it up as private, federated, or public chains, and they all benefit from that wider layer 1 trust base. The whole ecosystem gets more trustworthy as more chains join in. Another feature is hypersharding with cross-chain bridges. Basically, splitting the workload smartly for speed, but keeping everything connected seamlessly, like one big, fast, partitioned chain. But maybe the biggest advantage is the off-chain native cloud computation and big data analytics. Smart contracts can just directly call microservices on Leviatom or AI models on Behemotum, and that execution is verifiable off-chain. This is like the ultimate scaling path for EVM chains, using external trusted power for the heavy lifting.
Incredible. Okay, so the smart chain handles the core logic super efficiently. But what about the software itself? Making sure the smart contracts and microservices are actually built right and stay secure. That's a massive challenge in Web3.
Absolutely critical. And that's where Divina and Triathon step in. Divina is all about tracking and verification. It logs the entire build process for every piece of software, whether it's a layer 1 smart contract or a layer 0 microservice. Everything is traceable back to the source code, the build environment. Super detailed. This also helps bring existing Web 2.0 apps, cloud-native ones, over to run on Leviatom and Behemotum. And it's designed as an open ecosystem with incentives to get developers involved globally.
Okay, so Divina ensures the birth certificate of the software is trustworthy. What about Triathon? Is that the ongoing security check?
Yep, Triathon is the security guard, basically. Focused on ensuring things are secure and reliable, using this advanced AI-driven testing framework. It uses standard stuff like static scanning, dynamic fuzz testing, throwing weird inputs at things to see if they break. But the really cool part is it's AI-driven testing and real-time threat monitoring. It had this self-training AI model, uses reinforcement learning. They compare it to AlphaGo, constantly getting better at finding vulnerabilities. And the community helps too, getting rewards for contributing to making it smarter.
Right, so layer 1 isn't just about speed, it's also deeply focused on the integrity and security of everything running on it, the engine connecting trust and resources to the actual logic.
Precisely. It creates that robust, verifiable, scalable environment needed for everything else to function safely and well.
Okay, finally we get to layer 2, the service layer. This is where users actually see the results, right? Where all that foundational power turns into real, usable, decentralized applications. What kind of specialized dSaaS are we talking about here?
Yeah, this is where the rubber meets the road. dSaaS is decentralized software as a service, solutions that really use the whole NetX stack. We've got three key ones mentioned: Tusima for finance, Ethanim for the metaverse, and Octavius for AI enterprise stuff.
Okay, Tusima. DeFi is huge, obviously, but privacy and meeting regulations are still major pain points. How does Tusima tackle that?
Tusima aims for full stack privacy in finance, so it can handle transactions that meet regulatory rules, but also hide sensitive customer asset details from the public chain view. It's designed for high performance, strong data privacy, making data available off-chain, handling cross-border payments, and even data securitization, letting people maybe earn from sharing data safely. A really key piece is its trustless cross-chain bridge. It uses zero-knowledge proofs for security. This allows secure communication between different chains, helps with the NetX Smart Chains hyper-sharding, keeps data isolated when needed. It really hits those core DeFi challenges: privacy, compliance, scale.
This sounds like a big deal for making DeFi more practical. Then Ethanim for the metaverse. AI-generated metaverses, how does that use the stack?
Right, Ethanim is focused on AIGM, AI-generated metaverses, and also XR, extended reality. It provides decentralized logic for metaverse apps, so things are fair. Decentralized rendering, so visuals aren't biased. And privacy-preserving data storage. This gives users control over their digital identity, their data, and lets them potentially securitize it. It also stresses making NFT assets work across different applications so your stuff keeps its value and you stay in control. And a big goal is training personalized AI models based on what users like, making virtual worlds really tailored to the individual.
A user-owned private metaverse where digital stuff actually lasts.
Cool.
And then Octavius. AI-driven enterprise services. Sounds pretty advanced.
Yeah, Octavius is about automatically managing complex business applications. It's designed to generate smart contracts just from plain language instructions. Imagine telling it what you need and it builds it. It talks directly to Leviatom for computing power and Behemotum APIs to access data. But what's really cutting edge is how it learns and improves within the NetX ecosystem. It works with Triathon to find bugs, tells Divina what needs fixing or new features, uses Ethanim to understand how people behave, even optimizes token incentives for other projects using Tusima. It's pushing this idea of human-machine coevolution, superintelligence, aiming for truly autonomous Web 3.0 systems that adapt on their own.
Wow. That really shows how the whole stack works together for these very specialized, smart, user-focused services. What really strikes you about how these Layer 2 services use the lower layers? Is it just building on top, or is it deeper?
Oh, it's much deeper. It's seamless integration. These dSaaS solutions, Tusima, Ethanim, Octavius, they literally couldn't work as described without all the pieces below. They need Layer 1's trust, Layer 0's resources, Layer 1's scalable, secure environment, like Octavius learning and evolving that totally depends on trusted computation from Leviatom, verifiable testing from Triathon, all rooted in TRIAS' trust. They aren't just built on the stack, they're kind of defined by it, you know?
Right. It's clear they aren't silos. They really are one integrated system. So how do all these connections, these interdependencies, actually boost NetX overall, make it, more than just the sum of its layers?
That's the core idea of the chain-native technology stack. It's the synergy. Layer 1's trust from TRIAS makes Layer 0's resources, Leviatom's compute, Behemotum's data, reliable. Those reliable Layer 0's resources then let Layer 1's NetX Smart Chains scale massively using off-chain power, while other Layer 1 parts, Divina and Triathon, make sure all the software across Layer 0 and Layer 2 is solid and secure. And then Layer 2 services, Tusima, Ethanim, Octavius, they get to fully exploit this secure, scalable, private foundation built by all the lower layers. They turn the whole vision into real applications. So what you get overall is, better security from that deep trust, strong privacy, amazing scalability from off-chain power and sharding, and just a lot more flexibility for building apps. It all points back to that vision, a powerful, secure, scalable, private, small data network.
Okay, that was a really thorough look at the NetX architecture, really comprehensive. For everyone listening, if you had to sum it up, what are the main takeaways? And maybe were there any bits where the info felt a little incomplete?
Sure. The main thing is to grasp what each layer uniquely brings. Layer -1, TRIAS. That's your foundation of trust and cybersecurity, non-negotiable. Layer 0, Leviatom, Behemotum, the powerhouse for decentralized compute and private big data. Layer 1, NetX Smart Chain, Divina, Triathon, the central engine, scalable EVM chains, solid software integrity, advanced testing. And Layer 2, Tusima, Ethanim, Octavius, the application layer, specialized dSaaS for finance, metaverse, AI. Together they build towards that NetX vision of a decentralized, secure, efficient, small data network. But yeah, the couple of things that provided info doesn't really detail, like the specific tokenomics for the entire NetX system, beyond just incentives for specific projects like Divina or Tusima, and a formal overall governance structure for the whole NetX ecosystem isn't laid out explicitly. So those are areas where we don't have the full picture just from this.
Right, good points. This layered approach definitely gives us a lot to chew on, especially how that verifiable trust and those integrated resources are just so fundamental for any real decentralized future. What's maybe one final thought you'd leave people with about NetX's whole integrated approach?
I'd say really consider the potential of these truly integrated blockchain stacks. NetX is a great example. It shows that Solving the big problems in this space isn't just about, say, a faster chain or more secure contracts in isolation. It's about designing the whole system, top to bottom, where every layer from trust right up to the services strengthens and enables all the others. It's a really compelling blueprint for how future decentralized systems might tackle complex real-world challenges effectively.
A powerful idea, yeah. The need for that cohesive system. Well, thank you for joining us on this deep dive today.